This is a demo of BeAFix, a tool to automatically repair faulty alloy models. BeAFix is built on top of Alloy Analyzer and uses a bounded-exhaustive search algorithm and mutation operators to find a repair. Search space size is reduced by using sound pruning techniques. As an example, let us consider a file system specification. As signatures, we have objects of the file system, objects in the file system, the root directory, a parents and a contents relation, and we also have a related fact stating that all objects in the file system are reachable from the root, and the parent and contents relations are the converse of each other. The specification also contains two predicates, move, which moves an object to another directory, and establish a relation between the original file system and the one with the moved object, and remove all, which recursively removes an object. Finally, the specification has four properties. Both move and remove all should have satisfying instances, and both move and remove all predicates should have the expected behavior. As we can see, our model does not satisfy the properties. BeAFix does not have an integrated fault localization technique. It depends on existing techniques to locate the faulty expressions. In this case, we will consider that we already know which expressions are buggy. For BeAFix to work, we need to mark the faulty expressions using a specific mark, while also specifying related variables to those expressions. With the buggy expressions marked, we can now use BeAFix to repair the model. Candidates will be visited in breadth-first search and without any pruning. After a while, BeAFix will output a repair process report. In this case, a repair has been found. We can see the last visited candidate, both original expressions and the repair expressions, and we also get more detailed information of the repair process. We can now try one of our pruning techniques, variabilization, which will check for each mutation on move's expression and ask if there is a possible way to change the expression at remove all to make all assertions pass on specific scenarios. After a while, we reach the same repair as before, but visiting around 1,000 candidates less by using variabilization. Finally, we can now try with both pruning techniques. Adding partial pruning, this technique will check if there is any failing property which only depends on expressions that will not be mutated while pruning mutations on the other expressions. In our case, candidates where the expression on move would remain fixed while trying mutations on the remove all expression. We again obtain the same repair from BeAFix, but visiting about half of the candidates we visit without any pruning technique enabled. BeAFix information and replication package for our evaluation can be found at these URLs.